Our group is going to talk about the metal filling process in TSV, which is being commercialized as the latest technology. Due to leakage currents, the development of two-dimensional single-chip integration has reached its limits, and three-dimensional packing technology is being researched to increase the integration of chip and to combine various functions on a single chip, and TSV is one of them. TSV, full name through-silicon via, is the technology that makes hole in the front and back of silicon wafers and fills a metal-like conductor to electrically connect them. TSV can be classified into three major categories: via first, via middle, and via last. TSV manufacturing process consists of four major processes, and we are going to deal with metal filling exactly in process number 2.
We will focus on the copper electroplating metal filling method and its problem. Copper is most commonly used material in metal filling because it has low resistivity, resistance to electromigration, and its cost is low relatively. Electroplating method is often used to fill the via because it can produce filling with good uniformity. Copper electroplating requires a power supply, an electrolyte and two electrodes. Electrons are removed from anode, while copper solid deposit at the cathode, which is the seed layer deposited. Electrolyte is added with some additives to improve the uniformity and prevent pinch-off effect. However, there are still some problems with this method. First, for high aspect ratio TSV, void and seams can happen and affect the device performance. Next, seed layer need to be deposited before electroplating, but the process has low throughput, high cost, and low sensitivity. Overburden layer will also occur, so CMP need to be carried out to remove it, and this increase the cost and time consumed. Finally, the mismatch of thermal expansion coefficient between copper and silicon can cause thermal strain that lead to delamination.
To overcome extrusion problem, filling TSV can use copper tungsten electroplating. This is a method of filling TSV through electroplating by alloying tungsten, which has a relatively small difference in coefficient of thermal expansion with silicon with copper. A plating base is prepared using a complex agent, accelerator, and pressure agent. Filling vias using purpose periodic resolve PPR electroplating. PPR waveform is useful for reducing defect in the electroplating coating, and it is used to electroplating inside the TSV. For the result, the copper-filled TSV has voids and crack on the surface. However, the copper tungsten-filled TSV did not. Copper-filled TSV show a lot of extrusion, while copper tungsten-filled TSV was significantly suppressed. Filling a high aspect ratio TSV takes a very long time and voids cannot be prevented. To solve this problem, Indium is filled into via TSV using a method called vacuum-assisted liquefied metal VALM. The material used to fill the thick wafer is indium bead, a superconducting material. VALM method uses vacuum and heat to fill the wafer with indium. Through this process, the desired shape of via field can be obtained. Filling vias with indium using the VALM process allowing for quick filling. It only takes 10 minutes to filling vias. Also, as shown in the picture, there are no voids. Using the VALM, the temperature of the filling process can be maintained below 16 degrees, resulting in high yield of 19%.
So, next method of filling TSV hole is nanosilver particle filling. This method is low temperature process and not requiring CMP process, which is expensive and divided into two processes, fast and slow processes. So for filling silver particles, we need to print silver particle using 81 weight% solvent by screen printing method. Next, we need to repeat squeeze and evaporate process to get rid of bubbles and overburden layer in the silver filling. Then the process is divided into fast and slow process. Fast volatilization process forms liner at the end of the process, and slow volatilization process forms bottom plug and liner at the end of the process. So by repeating this slow volatilization process for 3 times, silver is fully filled in TSV holes. The next method is high-speed molten solder filling, and this process only takes 0.5 seconds, which would result in high productivity. And the process of molten solder filling is simple. By generating vacuum and pressure difference, we can fill the TS3 holes with SAC305 molten solder. Of all factors, filling was affected largely by vacuum pressure.
Metal filling is very important in that it electrically connects the up-down stacks and accounts for a large proportion of the total cost of the TSV process. What material to use and what method is used to fill the via is directly affect the performance of TSV. In the typical TSV process using copper electrochemical vapor depositions, there are three major problems. First, the time-consuming, second, the expensive cost, and third, the risk of surface delamination. We suggest the following four methods to solve the copper problems. Thank you for listening.